7.2 Inverses of relations and functions. So what you have to do, you have to graph each function, then write and graph its inverse. So for second period, you're doing f of x equals x plus 2 over 3, and you need to do it in a green color or color pencil. For third period, you're doing g of x equals 2 over 3x plus 2. For fifth period, h of x equals 4x minus 3/4. And for sixth period, f of x equals 2x minus 5 all over 2. And it's due on Thursday at the beginning of class. Okay, so let's start with relations. A relation is a set of ordered pairs. So we have the following relation, x and y, with the following order pair, 2 and 3. The inverse of a relation is when you switch the x and the y values in each order pair. So the inverse would be, we're switching the x and the y, so the inverse relation would be 3 and 2. So what does this mean? Well, when the inverse of a relation or a function, it will change the domain to the range and the range to the domain. So let's do another example. What if we have the following relation? Relation on x and y with the following order pairs, 0 and 2, 1 and 4, 2 and 5, 4 and 6, and 8 and 7. This is your input, and this is your output. Your x values are your domain, and your y values are your range. The inverse will be 2 and 0, 4 and 1, 5 and 2, 6 and 4, and 7 and 8. As you can see now, the range became the domain, and the domain became the range. So what if we have a function? For example, f of x equals 2x. To find the inverse of the function, we want to undo the function. So for example here, the value x is multiplied by 2. So to undo this, we would divide. So the inverse function would be x over 2. Another way you can find the inverse function is by writing the original function with x and y switch and then solving for x. So let's do the same function. F of x equals 2x. So we want to rewrite it as y equals 2x. Then we want to switch x and y. So now we have x equals 2y. And now we want to solve for y. So divide by 2, divide by 2. So y equals x over 2. So our inverse function is x over 2. As you can see, we got the same answer. Now to check, let's use an input. What about x equals 1? So let's plug it in into the original function. F of x equals 2x. So if x is 1, then we have 2 times 1, which is 2. And that's our output. This was our input, and this is our output. So now for the inverse function, if we plug in the output, we should get the input. So we have the inverse function, which is x over 2. Our output was 2, so the inverse function, when x equals 2, is going to give us 2 over 2, which is 1. As you can see, we got the input back. So the inverse function does undo the original function. Now let's do another example, and this time we will graph. So what do we have f of x equals 3x plus 6. So we want to rewrite it as y equals 3x plus 6. Now we want to switch our x and y. So then we're going to say that x equals 3y plus 6. If we solve for y, we want to subtract 6 from both sides. So we get x minus 6 equals 3y. Now to solve for y, we want to divide by 3. So divide by 3. So we can say that y equals x minus 6 over 3. If we simplify, we get x over 3 minus 2. And this is our inverse function. So to graph it, okay, to graph f of x, we know that our y-intercept is 6. And our slope is 3 over 1. So this is our graph, f of x. Now the inverse graph is always reflected across the line y equals x, which is this line. So then the inverse function looks something like this. And that's how you write the inverse of a function in the graph.